This is a question from the textbook. You're asked to solve this particular equation. Now, if you can see, there is a square root sign here. So you need to square root both sides before you can do anything, because now all these terms, these three terms are trapped inside this square root sign. So you square both sides. Now, once you square both sides, what happens on the right is that the square root and the square sign here will cancel each other out, leaving only these three terms. On the left, you have to apply this identity which you learned in Sec 2. Okay, so you square this, and then this times 2. That's how you get this. Alright, so square this, you get this, square this, you get this, and then this times this, you get minus 2x cubed. Then you times 2, you get this. Now, what you need to do is to make the right hand side 0. So you minus 2x squared both sides. You will end up here. Okay, combine with this, you will have this, and then plus 4x both sides, minus 3 both sides. Okay, you need to make the right hand side 0, because if the right hand side is not 0, you cannot solve. Now, if you were to look at this, it has become a polynomial, but it is a polynomial with degree 4. So under your syllabus, it is only degree 3. That means you're only expected to solve polynomials of degree 3 such as this. Okay, so how do you do this particular question? It's not going to come out in the exam like that. They at most will ask you to manipulate, and then you'll come out as a cubic equation, because as you will see later, the steps become quite repetitive, and O level they will not do that to you. Okay, now, but having said that, how do I solve this anyway? Again, use your calculator. Okay, but instead of power 3, degree 4, key in 1 minus 4, 2, 4, and minus 3, and you'll get the answers for x. Okay, so I choose the number 1. Okay, that means one of your x answers are the roots. One of the roots is 1. Okay, I choose 1 now. The other roots, I think, is 3 and minus 1. Okay, we'll check it out later. Now, but before you could do that, you do notice that there is no names given to any of the equation or function here. So what you need to do is to call this by a certain name, f, so that you can f0, f1, and whatever later. Okay, so this step is important. After that, you sub in the 1, and of course you will get 0, because your calculator already tells you that this is a root. Okay, then when you continue, you need to write this. This is important. You need to state this very clearly, because what you're applying here is what we call the factor theorem. Okay, the factor theorem. Alright, now we do have a problem, and the problem is that you cannot f all the way, whatever you see on a calculator, because even if you have done that, you'll find that there are missing terms. Okay, so what we need to do is, for this particular question, we need to do long division. Okay, as I mentioned in class, I will try to avoid long division, but if you were to try to so-called use the compare coefficient method, which I always do in class, you will find that it's actually quite tedious. Of course, you can get the first and the last term, okay? Because this times this give you this, and a number times minus 1 give you this. That means it has to be plus 3. Okay, so effectively I gotten this and this, right? But there are 2 unknowns here, which means that I need to probably plus mx plus nx. That to solve for 2 unknowns. So if you do attempt to do this question using this approach, you will find that it's very tedious. Okay, so mathematics teaches us, or rather when you study mathematics, you have to know that there are many ways to solve the question. You are now being trained to pick the most efficient method. Okay, now after I've done long division, you can try doing long division, okay, because it's part of your syllabus and you're expected to do that. So treat it as a revision. Okay, so the reason why I'm willing to go through this question is because every step of the way you're actually doing revision. Now, after I've done this long division, I can now rewrite this into this, but again, I have another problem, and this is cubic. Okay, now this is in your syllabus already. That means they will ask you to factorize this. All right. So how do I do it? Same old story. Now you have to give this term, this side, this right hand side bracket. Okay, another name. All right, it's no longer fx because fx is this times this. This on the right hand side of my finger, you have to give it another name already because it's no longer fx. All right, you have to give it another name, and I choose gx. Now it's the same old story, whatever you've been doing in class. This should be very familiar from now. Again, press calculator and you would have gotten all the answers for the x values of this gx. And you sub it in. Okay, again conclude that x minus 1 is a factor. So this is another step. This is another step. So it's like step 1, okay, step 1 here, step 2, step 3, step 4. Okay, and after this it becomes quite repetitive. Okay, after this it's the same old story, and that is when I am going back now. Can you see that up here I'm actually doing gx, but now the main character of my story is actually fx because the original thing that I want to solve is fx. Okay, so I am going to go back to this fx story, which is this story. All right, I hope you're not confused here. This part here I sidetrack a bit in order to find out what is the factor of this, one of the factor Okay, so this part here is your gx, whereas what you want to find actually is the fx. Okay, so now I have to know x minus 1 times what gives me this gx. And if I were to compare the coefficient, remember I always settle the highest power first. Okay, so it has to be x squared here, and now the lowest power, which is a constant, this is minus 1, so it has to be minus 3 in order to get plus 3. And that is when there is an unknown here. Unknown, you go and call it mx, px, or whatever x you want. Okay, oh sorry, I call it p, so I have changed to p. And right now you have to compare coefficient, and you have to be very careful. We are dealing with gx, which is this. We are not dealing with fx. Okay, so when you compare coefficient, don't compare coefficient of this x. You have to compare the coefficient of this x. This x, which is the gx. Alright, so I'm comparing coefficient of x, so I multiply this x with, this one, nothing to do with this fella. I'm comparing this and this. That's how I get minus 3 here, and this with this, because I want coefficient of x, so it's minus p. And on the left hand side of which is the gx is minus 1. From here you'll be able to get p equals to minus 2. Sub into here and you will end up with this here. And because you are solving it, so you have to put equals 0. Okay, this is important now. When you are solving something, there has to be an equation. You cannot say oh, I don't put equals 0, then you do what I do here. No, you'll be marked wrong. Okay, you have to write it as equals to 0, because only with an equation then you're actually solving. Alright, now this is actually this is actually this, so there's nothing you should do. You just need to factorize this and you will get repeated roots. Okay, repeated roots. So you have 1, 2, 3 answers. But as mentioned many times, you have to check against the original equation. Because why must check? Why must check? Normally we don't check, right? Because of the square root sign here. Okay, and when there is a square root sign, sometimes there are numbers that you have to reject because you cannot square root a negative number. And true enough, you have to reject this one. Okay, go and try and you'll know why. So it doesn't mean that, oh, the x is negative here, I have to reject this. No, can you see that for this particular question, you actually reject, you actually have to reject the positive x one here. Okay, and you actually accept this. So you go double check and you'll know what I mean.